Hey everybody, this is Larry. This is day 19. Yeah, of the Leetcode April Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I played softball earlier today. I'm really tired, so hopefully this will be good. And we lost on a very heartbreaking walk-off loss. So yeah, I did okay, in case you're wondering. But anyway, you didn't come here for that. So anyway, today's problem is we cover binary search tree. So hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Let's see what's going on here. Okay. This is a medium, and basically you have what's going on. There's two nodes of the tree that's swapped by mistake. The first thing I would maybe do is see if there's any like constraints, like are they unique and so forth. A solution. Okay, so O of n is pretty straightforward. So they say it's always easy when you know. You can do a space. That is interesting actually. I wonder if this is one of those like Morris traversal type thing, because you have to look at every node, and it's going to be O of h because of the height of the tree. I'm not a fan of the Morris traversal, to be honest, just because it does like manipulate the lengths, right? So it's a little bit awkward, I think. But maybe that's not the solution. Let's think about what we want to do first, right? But how do we think about this? So there's at most 1,000 node. See if we could do it in linear time or something. So 1 and 3. So I guess what we're trying to think about is how do we detect that the invariant has been violated, right? The invariant being that in a binary search tree, of course, and we've been doing this all week, which is actually, I guess, my weak point, now that I think about it a little bit, because it doesn't really come up that much in competitive, or at least not quite directly like this. So the invariant is, of course, for every node, everything to the left is smaller and everything to the right is bigger. And then now let's think about how we can see where that node is, right? So we can definitely so there are two. I mean, I don't know. There are a couple of cases, is what I want to say. I haven't counted them really. One of them is that in this case, right, where the node that is violated is. Do we have a unique answer? Yes, that's a question. Doesn't really seem to say. But yeah, there are 2 or 3 different possibilities that we can maybe enumerate. That's the first thing I would maybe think about. One is that because I don't think it's necessary. I mean, the examples that they give you has like the quote unquote the root node being an issue. I don't think it necessarily is true that you have a parent, right? Because you can have something like even something as simple as wait, I was gonna say something. Maybe it is. Let me think about this. Maybe there's like a proof by contradiction thing. Because I was gonna say something like, let's say you have a tree that's like, okay, let's say 10. I'm doing ASCII art. So you have 1 and let's say 15, right? And then this goes up to something higher. Let's say it's, because I was going to try to create, let's just say X for now. And then this is like another thing. And I don't think this is true, but this is what I was thinking of, right? So then I could have maybe something 13, right? And then 25. So everything is good, and I want to get to a case where these 2 things are swapped, right? But I don't know that can be true, because in this case, I don't know the principle, but maybe it's just a principle of like observation, the power of observing, right? Because I was going to say that if this is the case, that means that like what can X be, right? That means that X has to be either, well, let's say it's 14 maybe. Like well, I mean, obviously there are only 3 scenarios that we have to think through, right? One is that it's bigger than both numbers. So let's say this is 16. If this is 16, then actually you cannot, or you don't need to swap these 2 numbers. I think you just swap the is that true? I mean, if you swap these two numbers, well, you cannot swap these two numbers because it still would be wrong, because 15 would be on the left side, but then it will be smaller than 16, right? So this one doesn't work just by contradiction, maybe, or like exhaustion of trying every possibility of you can, and you cannot swap 15 and 16 because it just doesn't work. And then if you swap 16 and 13, it's still not true, right? So there's no possible way to resolve this. So that cannot be a possible input. Okay, let's say the other x is 14, right? Something in between. Well, in this case, swapping them obviously works. And then, but the swapping 15 and 14 doesn't work. Swapping 13 and 14 also doesn't work. So I guess in this case, yeah, so something like this, you can swap the left and the right. So, so that is one scenario, right? And obviously the other scenario is just, in the examples where you have a node and then either the left, something in the left is not right or something in the right is not right. This is a medium, but to be honest, I feel like this is hard for me. Unless I'm missing something like really obvious that I'm just kind of rusty on. I think I'm right on this one with respect to this example. Hopefully I'm not, because otherwise that's a little bit sad. Okay. So then I think those are the two possibilities, is that given a node, yeah, I'm trying to think whether now, like, I guess we can actually, like, it doesn't have to be a leaf, right? Because this can, well, this cannot have right node, but this can have a smaller node, like 12, and then if you put in the 13, it should be okay. So okay, So then how do we find these two nodes, right? Even in linear space. Wow, maybe I don't know how to do this. Okay. I do struggle from time to time. 13 and 15. All right, let's go. I'm trying to think about an invariant that I can do, but yeah. And again, I'm trying to not do the Morris traversal, so I'm just going to do a regular depth first search. But I feel like Morris traversal is kind of dumb anyway. If you ask me, feel free to disagree with me and then, do your thing. I mean, it's not dumb. Sorry, I don't mean to say it's dumb. It's just, I don't know. I'm okay with not knowing it. But let me think. I guess I think I'm just trying to avoid the O of, I guess O of n space is very easy, in that you can, do an in order traversal and then you can kind of see that like if this is bigger than that one, then in this in order traversal you have 1, 10, 12, 15, 14, 13, 20, 25, and you can see that two numbers are out of place. Yeah, right. So that part is obvious, but then my question is, can I do this in a cleaner way that doesn't require like an in order traversal type thing? 14. I mean, I guess we can just keep track of stuff. Yeah, okay. Let's play around with that, and then I guess we'll see with the in order traversal. Because there are things you can abstract, but I feel like maybe that's fine. Is this the only thing? Let me think about. I'm just trying to think about other cases, so that I can make it maybe easier by must. In this case, 13 has to be bigger than, or the next number has to be bigger. So this could be 16. But does that mean that I'm trying to think whether there is a case where, like, is it always 2 steps away? Right? Like, is there a case where, no, I guess that's fine. Let's say pretend that this is 15, then, well, I already used 14, so this is awkward. But let's say this, okay, let's remove this, and let's say that this is 12. So we have the same condition. But then here we can have 13 here. But this 13 obviously is not going to be smaller than 12. I think that's what I was looking at. Okay. And here we have, say, 16. I think that's fine. Okay. But in this case still, no, okay. So that could be far away. Okay. Also, this is, well, this is not 13, is it? This is, say, well, let's say this is 13, then this is 14. That's what I mean. Because then now, go 13, 14, 12. So it could be like far away. So we have to find the, so in a way, we have to find the first instance that in an adjacent in order thing, given an in order traversal, we have to find the first instance that the number is swapped, and then the second instance where that is true. Okay. Okay. I mean, I think we got this. Very slow, but I think we got it. I'm trying to do it also without explicitly like just doing it in order. I think if I was to do this in a contest, just to kind of be a little bit disclaimer, if I were to do it in a contest, then I would probably do an in order into an array, and then given that array, you can just look at adjacent elements, and that would be pretty straightforward, relatively speaking. But here, let's kind of yeah, let's do it kind of recursively. Let's say we look at the previous node. Just you go to none. Okay, let's just say in order again. It was none, then we return. Otherwise, we do in order node dot left. Oops. In order node dot right, and then now we process the current number, right? So then the current number we are going to say, whoops, node. If previous node is not none and previous node dot value, if this is greater than this node's value, then what happens, right? That means that this node is bad. No, that's not true. Well, that means one of, so the first time that this happens, we want the previous node, and then the second time this happens, we want the current node, right? So okay, this is a little bit awkward, but we'll play along for now. You know, if length of we want to pen the bigger node. No, we want to pen the bigger node, which is the previous node, and then else we want to append the smaller node, right, which is node dot value. Okay. Oh, node dot. Yeah. Okay. I think this is maybe okay. I have to do some updating of the previous node, of course. Previous node is equal to node, and then here we're doing in order of the root, and then let's just print it out. Why not? Okay, so we print out the node 3 and 1, and I think that's maybe okay. Okay. I didn't really do a good job of, but that's fine. Okay, so that means that, okay, a sub 0, or, well, let's assert that length of array is equal to 2. And then now we can swap the values of the two arrays. Okay. Really? Let's take away this one for now. Maybe that's not true. Okay, so this is good for this one, but maybe this is not true for this one where, like I could imagine like some case. Oh, because the two adjacent elements. How would I check for that? That's a little bit yikes actually. Okay, so this is 0. Then that's also if length of R is less than 2, then we do this. Otherwise, R dot 1 is equal to no. Okay, this is very awkward. My code is yikes, but if it works and it's, you know what they say, yeah, beautiful code and doesn't work, it doesn't matter how beautiful it is. That's an excuse. My code is kind of awful, but at least if it works, I won't feel so bad. So let's give it a quick submit. Oh wow, I've kind of wrong a couple of times previously. Yes, past Larry's. Haha, 749. Past Larry, I've done it wrong. I guess I always struggle with this one. Maybe I just have like a set of problems where I struggle with. But got it wrong twice the first time, got it wrong once the second time, and this time no wrong answer. Even though this is a long video, I think 17 minutes. Yeah. Cool. And of course, if you want to do it in, so this is linear space, just because that's how in order traversal works. It's O of h, where h is the height of the tree. You can get this O of 1 with Morris traversal. I'm not a fan of it in general because it's just like a keyword that you can kind of plug in. But maybe I should learn it. I don't know. Let me know what you think. Yeah. Cool. That's pretty much all I have. Yeah, let me also write linear time, linear space. Yeah, because you have to look at each node once and the linear time comes from in order. So yeah, that's all I have for this one. Let me know what you think. My neck hurts. Anyway, hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great rest of the week. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.